Hello guys, hope you're doing great and apologies for the previous video where I had feeble voice. Hope it doesn't continue in here. So we knew or we learned about the importance of containers, why we would require containers and how actually it can be implemented in your infrastructure and what benefits actually it has to offer and what else it can do apart from the virtual machines. Okay, so let's go with Kubernetes. Now we will discuss more about Kubernetes. Why exactly Kubernetes came into the concept, because containers concept was bought by Dockers, and they were able to run the containers and there were no issues. Okay, the problem, the the more the applications become modular, more the approach went towards microservices. It was real hard to manage the containers which they were spinning, because in the production the containers which they spin, it's not one or two, it's gonna be 50 plus or 100 plus containers. So that what is a issue which actually led to the evolution of Kubernetes. So that's one thing. So Docker Engine was not able to handle the production workloads. And then in fact what I can say is, like, it was pretty hard for the admins, also cluster admins, also to manage these many containers in production. So what are the capability which were missing in the Docker offering or any other vendor offering, were like this, like how how about using multiple containers with shared resources. So shared resources, if they have like databases or something, if they are written, there was no proper mechanism which could handle, the engine could handle setting up the connection, closing of the connections, and load leveling the connections, and consistent making persistent the consistency in setting up the connections, and pulling the connections were not there with the earlier solutions. So Kubernetes do it in a very well way. And the second is the monitoring all of the containers which are running. So containers run, and they run in their own logical boundaries, right? So it was not easy, not much easy to set up a monitoring solutions on top of it and then use it, use it by any of the Docker engine or any of the other offerings which were done earlier. But with Kubernetes, what happens, the master server, the AP server, actually keep an eye on all the containers which are running underneath it, and then it actually takes actions if any container dies. So that's one thing. So Kubernetes handles dead containers very great. What happens is, like, if the API server sees that container is dead, then it would spin with another container. So it take a reference from the deployment, which we actually do by defining an YAML, which we will try to learn, or where I'll show the demo in the next videos. And moving containers, so that the utilization improves, like, take an example, like, if there are containers which are running and there are not much requests which are coming. So containers are what? Containers are the package of application, right? So if there are no requests coming to applications inside that particular container, so what Kubernetes would do is, like, either it would scale down if it has number of replicas, number of copies running, or it would actually move to another node or to another virtual machines where there is a node capacity is there, and it can utilize that particular space instead of keeping another node and running the container on top of it. So this all managed by Kubernetes. And the another thing is auto scaling. So auto scaling container instances to handle load was one of the best feature, because when the deployments happens on cloud, and cloud has a capability of scaling, and if the Kubernetes cluster, if it do not give that particular capability of scaling the services, then it could have been a big issue. Because the infra underlying, if you're hosting this particular Kubernetes services on Azure, it it is called as AKS. If it is hosted on Amazon, it is called as Elastic EKS, Elastic Kubernetes Service. And with Google, that's Kubernetes, because that's what they have built this, they have developed this particular product. So auto scaling was very necessary, and it came, and it has helped a lot in the production systems. And the other thing, making the container services easily accessible, like The concept of ports, the concepts of ingresses and other particular mechanisms had made developers life easy and to configure, or the DevOps guys, engineers life easy to maintain it. And connecting containers to variety of external data sources. One particular example which I want to talk about is like if you have a running container inside your cluster, inside your Kubernetes cluster more precisely, how about connecting or storing your secrets somewhere in Azure Key Vault or any of the Key Vault repositories? Okay, so this was not possible with Docker. You need to explicitly write some code and build that particular image and then deploy. But this is possible with Kubernetes, where you just need to give access to the Kubernetes, the access to your Azure Key Vault, and then the contain the whatever programs or pods can actually go and access those particular secrets which are sitting on the Key Vault. So that is one particular example. Yes, databases and other things also other examples which we can pick it up. And so we will go to the what Kubernetes can do for us. So it's portable, it's extensible, it's an open source, and we can well manage our containers, applications and services with this. And the other benefit is like Kubernetes provides not only a manual way of handling tasks or pod, you can automate and you can manage all of your containers. And what are the benefits of using or uh, managing pods or containers using Kubernetes is like, you can uh, do an keep an intelligence, and you can do a load balance and schedule your jobs on the containers. You can schedule your request onto the containers across multiple replicas, so that you always uh, load balance your requests which are coming from the external world. And another thing is like creation and deletion and movement of containers was very pretty easy mm, uh, with Kubernetes, because Kubernetes itself take the responsibility of uh, creating a new clusters on demand when you deploy, or even when it sees like there is no instance of that particular deployment it's running, then it would create a particular container, and it would also delete a container in case the container goes unhealthy, and in case like there are not much replicas of container or stamps, or instances of applications are running, then it can scale up and delete. And if there is a load dull, like the request number of requests which are coming are less to your applications, then it would scale down. So that's where deletion will happen. And also movement of containers, the movement of containers in the sense like clusters, basically clusters would run on node. So node are nothing but, you take an example of a virtual machine. Okay, so these clusters would run on virtual machines, or they can run on a bare metal, and Kubernetes will take care of moving those containers if any particular node or machine is less utilized. If you're spinning up, if you would have spinned up 2 to 3 nodes, and out of that the number of utilization, the CPU and memory are less, the number of requests which are coming are less, then it would try to scale down from the node from 2 or 3 to 1. And then it would also ensure to move that particular containers which are going to be the nodes which are going to be deleted or will be taken out of the pool. So Kubernetes take care of taking up the containers first, uncordon them first, and then take out the nodes from the pool. So that is one particular advantage of Kubernetes. And what other thing it can do is like the scaling of containers is pretty easy, and we talked about it earlier as well. And the monitoring and self-healing abilities of Kubernetes on containers had actually made a lot of difference. And how it can be used. Okay, so let us define the life cycle, or how you exactly you can use a Kubernetes cluster. So as I said, Kubernetes cluster can be used with Azure as AKS, and with AWS as EKS, and with Google as the Kubernetes service itself. So for that, you actually create Kubernetes cluster. So in Azure Kubernetes service, what happens, like Kubernetes creates its own resource group. So resource group is sort of logical boundary which it creates for its own nodes and other particular load balancer and IPs which Kubernetes cluster would create. And we will come to know, or if you want to refer about that particular how to create a Kubernetes cluster, then you can click on the title card, or you can find that particular AKS series which I made earlier in the description below. And it would create a Kubernetes cluster first and then deploy your app. So the app need to be in form of a Docker image, and then you can store that particular Docker image in a Docker Hub, or you can store on a Azure Container Registry. And the Kubernetes, they need to be given with access with any of the container registry repository or the Docker Hub. And then, like, you can actually, for Docker Hub, it's, you do not need an explicit access. By default it's open, and you can use the Docker Hub images and deploy your app. And then you can explore your app, you can see where your app is hosted, what is a service name, what is a and what is a port number, and on which particular node it has been posted. And you can check, the easy way is to open a Kubernetes dashboard and check this. And then you can expose your app publicly. So what happens, like by default, until unless you define an ingress, and then you ingress, and then you expose your service, you have your deployment, and then you spin it as a service. So when you spin it as a service, it like, if your image likely to be creating or explicitly want to expose your service to the outside world, then it would create a public IP in the dependent resource group which the Kubernetes cluster gonna prepare. And then, like, once a public IP is created, the service is exposed to via that public IP to the outside world. That's how your services inside containers will be exposed to the outside world. And then you can, during the deployment also, you can give replica, or at runtime also you can scale your app. And it's a very simple CLI way also you can do, or you can do from the dashboard itself. And then you can update your app with other images, or other version of your particular app images, either from the Docker Hub or the container registry. So that is the thing. And this is about how actually you can implement Kubernetes in your infra. We will be talking out in depth for further. And then this is a particular architecture, Kubernetes architecture, which has a Kubernetes master, and the Kubernetes nodes are these. And Kubernetes node has this particular components, kube proxy, C advisor, and kubelet, everything. And these are the pods, are the instances of containers which are running in. And the users can access directly because the services are exposed by the pods or container, and so the users can access directly. And they like, you can have in enterprise, you can have an API gateway, like app gateway, in fact app gateway of a firewall, everything you can define, and then via which the calls can come from the external users to your containers sitting in your on-premise or sitting on Azure. And similarly, the Kubernetes master is one particular thing which is responsible for managing all of this particular pods underneath this particular nodes. So if we talk about Azure, so the nodes, now what is chargeable and what is not chargeable is the Kubernetes master is managed by Azure. So this particular component, whatever time it runs, whatever number of amount of requests you are making from your kubectl, from your developer or operator or cluster admin perspective, is not charged. The only thing is charged is the number of nodes, or the SQUs you are running on Azure or in AWS. For that only, these cloud vendors, they will charge you. So this is one good thing, because, and this being open source, you don't have any licensing issues. But yes, the infra you are running, you will be charged on the infra, and the dependent resources which you would be running on top of it, you will be charged upon it. And then kubelet are the one way, like the kubelet commands are the one way, you interact with Kubernetes. So this is all about Kubernetes. Hope we will meet in the next video, and then we will discuss more about Kubernetes, and we will try to go into the Kubernetes basic. Hope Be connected and subscribe to the Isho Guy, and